My name is Ibemonde Kingsley, studying Network System Engineering. So this is a secure network solution for the FunOlympic Games in Yokyo. As far as a computer network is concerned, if it's not secure or reliable, then it is not safe to use. So the topology that we implemented in this network is the star topology. The star topology is designed in such a way that you will have a central device in a central location, which can be the headquarters of the games, and then you have other devices connected to it via a fiber optic cable to the other locations. So it's a centralized system that other locations depends on for connectivity. So we have some devices that are installed on this network. That is one, the multi-layer switch. This multi-layer switch serves as a switch and as a router at the same time. So it does the work of a switch and does the work of a router. So we have other devices like a DNS server, you have a streaming server, you have the edge router that points to the internet, then you have the internet Google server, you have firewalls, then you have an access point that gives IP to some smartphones that smartphones are connected to. Then you have other host devices that are connected to each locations. So the IP usage on this network is IPv4, IP version 4, and is a class A IP address, which is used for larger networks of this kind of magnitude, which is a games that several persons are connected to. So the assigning of IP address on this is with both static and DHCP. As you can see, you have static address assigned to these selected devices like the server, because we don't always want the server IP to change, so we assign to it as static so that we can always reference to it. The same thing with the DNS server and the other streaming server. So this will serve as a football server, and this will serve as a gymnastic streaming server. Then we also have IP allocated to these other host devices, but they use DHCP to assign IP to these ones. For instance, using DHCP server to get IP for these host devices, we configured a DHCP server on these multi-layer switches. For example, if you do a show run, on this, you will discover that you have this DHCP pool LAN 1 on this multi-layer switch that is used to derive IP addresses for these other host devices. For instance, this device, if you go to DHCP, you see it automatically assigns IP address to it. So that is how it works. If you check this, you already have a DHCP server giving it IP already. It's DHCP. So if you come to these smart devices, you can, this is already using a DHCP server as well. If you come to the smartphone, so you can get a DHCP IP address from this as well. So that is how it works. So the wireless access point is connected to the switch, so it gets its IP through the switch to the smart devices. This as well does not have an IP. So you assign IP to it with dynamic hosts. So that is how it works. So you come to routing protocol. So the routing protocol that is used for assigning for routing on this network is the OSPF. It is the protocol used on this network to route IP from one location to the other because they are in the same autonomous area. So OSPF is what we will use. And if you come to this switch, let's use this switch as an example. You log into the switch to show, you do a show run, you will discover that you have this is the OSPF profile running on this particular multi-layer switch. So this is how it is being configured. So you have a loop address. This loop address is used in case the switch goes down, that loop address does not go down. So it is used for testing connectivity to the multi-layer switch always. So that is how it is configured on all the switches. So if you come to this switch, you will also see the OSPF protocol running on it. If you do a show run, so you will see OSPF. This is it. That's the OSPF running on it. So it is used, you will just announce all the IPs, the static IP from the other locations on it, and then it goes for routing. Then to test for the connectivity of the protocols for the routing. So from here, you will discover that you can ping this server, the 30.10 server. So if you go to your command prompt, testing for connectivity, you can ping continuously to this server. So you see it's responding. So it shows that the OSPF is working perfectly from this network to this network. So from this network, let's try to ping this particular host, which is 20.2. So from this host, we want to ping 20.2 continuously. So you discover that there is connectivity from that location also. So that seems to be working perfectly. Then to test for internet connectivity, for instance, from this location, so there is a Google server that exists here that we can try to ping, or let's try to reach the web browser of that particular server, which is the Google server. So we can browse. So the Google server that was configured on it is .888. So you discover that you are able to reach that server. Welcome to Google, your best search engine. So internet connectivity is actually working. So some of the security parameter that we have on this network is a password on each of the devices, which is a very strong password system. So it's in it is a strong password system that if you do a show run, you will see that the password is actually encrypted. So even if a member of staff looks through it, he doesn't know the password except for the administrator that can log into it. So if you go to this switch as well, let me disconnect from the switch and try to connect back. You see that you have strong password system running on this switch as well. So you can see the enable secret is encrypted. So even if you look over the administrator's shoulder, you will not be able to know what the password is. So that is something that we should always implement on our devices. Then you have a firewall that is blocking people from the internet from accessing the streaming server. For instance, if you try to, because you have a web server installed on this server on the private network, it's called 10.2.30.20. so this is the gymnastic server. You see that it doesn't go through. So even if you try to ping it, let me copy that particular IP. So even if you try to ping this server, that is the gymnastic server, which is this, it doesn't go through. So the firewall has blocked it completely. But if you are inside the private network, like for instance from here, and you want to access the football server, this is the gymnastics server rather. So you will discover that you can actually access that server for streaming purposes. So if you are inside that particular network, the private network, you can stream the football event from here. Let's assume you want to stream the gymnastics server from here. The gymnastics server is the 30.20 IP address. So you can actually, okay, let's stream the football event. So you can see that you can access the football event from that particular, so that shows connectivity. So another security that we have on this our network is different VLAN system. You will see that on this particular area, that is the Stadium of Delight, you have the VLAN 30 running on it. So even if you are connected to this particular VLAN, you can stream services to other VLAN so far you are on the private network. So the security that we have here is that you have different VLANs on each location. So you have another VLAN running on this VLAN 20. So on this place too, you have VLAN 10. So that's another way of segmenting your network so that you can have proper allocation of IP addressing, and it helps in your security as well. So that is how the system works. Thank you.